Okay, sequential output of ASCII files. So we already talked about the buffered reader. So the buffered writer is the counterpart of the buffered reader. So back again to our simplified hierarchy here, right? So we've talked about the buffered reader and buffered writer. This time we're talking about. Okay, and so generally speaking, you always prefer buffered I/O, and the buffered reader is designed to work with text files, plain text files. Okay, so once again, there's this particular hierarchy we've looked at already before. I'm just going to close these views. Okay, and what else? So the output stream writer, which we see on this diagram, for example, is basically a bridge from character streams to byte streams. Because remember, at the operating system level, at some point, what happens is that it needs to write raw bytes. But we know that Java represents characters not as bytes but as Unicode characters, which are basically 2 byte size quantities, and so therefore output stream writer basically is the class which implements all of that low level set of facilities which are needed to convert your text into the low-level text, that needs to be written into the file. So sequential output of ASCII files. Sometimes you don't want to use Unicode. Sometimes you want to use ASCII files. So in the situation with ASCII files. By the way, I just want to explore just very quickly this dummy.txt, okay, which I was creating, and of course I was writing strings into this file. So I'd like to quickly open a binary editor and examine this file, right? So I'll say file open, file, okay, open this file, and what I'm going to do is that I'm just going to specify this location and go okay, just say go there, open this dummy, but open it as a open with, right, and specify that open it with binary editor just to take a look at the file. Okay, so by default, what we've been doing with our file writer, as you can see, there are no Unicode characters. The characters are stored nicely as sequential characters, and they're not Unicode characters. Okay, so but sometimes you want to work. So I was just going to find out, and I looked in the binary editor, using the binary editor to look at the content of my file. Right? So okay, fine. So I can minimize this. Maybe I can examine it later on. But actually, I will close this here, so another application doesn't interfere with my file. Let's take a look at this example. Well, perhaps I can just. All right, let's see if we really need to paste any of this into our code window. So let's see. So this is trying to work with the user. Okay, so this is why it's a longer program. So it's trying to tell the user. Okay, it's trying to tell the user. It's trying to use an input. Okay, and this input, where is my input? Okay, so we use the scanner, okay, and we create this input object. So this is keyboard input in many instances, unless there's some kind of redirection. We use an input, and this is all familiar scanner that we use. So we say input next int, and we ask for the employee ID number. then we say enter the name of the employee, and we say input next line. So perhaps to better understand how it behaves, let's just take the sample and compile it and see how it behaves. Okay, I'll just carefully copy all of this. Okay, and since this could be used in a separate file, I'll just place it in a separate file. So I'll just go to my sample and just go to my packages. Right, this is my package right here. I'll just say new Java class, right, and just the name of my class is going to be right here, right employee file. So I'll just copy and paste that, make a file like that, and then I will just once again try copy and paste all of this from the sample so we can see how it works and examine it. Okay, so I'm just going to preserve the package, right? Preserve the package and paste the rest of it. So I have a class name employee right employee file. So it says main, but I already have main in my main app, so I will just maybe rename it, not to confuse it with anything else, and name it right employee data, something like that. Really doesn't matter. I don't need any arguments here, so I'm just going to use basically this as a wrapper. I will keep it static so that I don't have to create the right employee data, right? So, but I'm going to go back to my main app, and instead of doing what we just did over there, what I'm going to do is actually, you know what? I think it may be useful for me to pass the directory location into this right employee file. So maybe I will say string, right? String, and use dir string as input parameter. Okay, use directory string as an input parameter. Okay, so right now I have this hard-coded path, but instead I will use my dir string, okay, and concatenate this with a name of the file. And why not, right? Employees.txt. But remember that we're using forward slashes, and of course, if this directory string does not include the trailing slash of any kind, I will use forward slash to separate the path, which looks like this, right? So my path does not have a slash at the end of it. So I will, to maintain the integrity of this string, I will use this slash to append it. Of course, I could do a better job by basically analyzing whether at the end of this directory string I already have a slash of some kind, but I'll just use the simplified version. So now I'm talking about the file that named employees.txt, and so let's make this call, write employee data. Okay, right? So we just go here, and once again we will say write employee data, and this will be a call into the class named write employee data. There is a static data method like that. I now will pass dir string into it, okay, and hope that what is it not happy about? I don't know. Hopefully I can find out if I compile this, right? What is it? Anyway, so this is it. So I can basically, for now at least, I can just remove all of this, and I will try preserving it just in case, okay, and I will just save it in the multi-line comment somewhere here. So this is something I no longer use, but I will preserve it. So right now, all my main method does in main app is that it just basically says write employee data, and it comes in here and executes the sample. So let's try building this just to make sure that we can build this, right? So we build this, everything builds, now we can run it. So employee ID number, okay, 123. Enter name for employee number 123, Joe, all right, and enter pay rate. I don't know what that is, like maybe like you know, $350 an hour. Okay, so it's just like really good good thing to do. Quit. Okay, quit. Input mismatch exception, or 99 to quit, sorry. So it's just kind of silly that I interpreted quit, that I need to print quit. But this worked, and if I go here, let's examine the employees. Oh, it's empty, maybe because I generated an exception. So let's try this again, right? Okay, we'll just run it again. Run it again. Employee number 123. Oops. 123. One more time. This is Joe. Okay, and then the pay rate is $350. Okay, good rate. 999. Okay, so we exit out. Let's take another look at this employee. Take a look at that. So here we go. We just created this record, 123 Joe 350. Okay, so this is what this thing does. Now let's see if it is capable of appending, right? So when we create this buffered writer, and we have this output stream writer. Yeah, I don't think this will be able to append any information. But let me try this anyway. Okay, so if I run this again, and I will say 456, then it'll be Alice. All right, and the pay rate is $200, and quit. Right, so let's take another look at this file. So what just happened there, that Alice basically, like I said, is replacing the original record. So this really doesn't have any code for appending the information, but nevertheless, what happens here is that what we're trying to use is we're trying to say output stream. Okay, so output stream is part of this hierarchy, and actually this specific sample, I apologize, this specific sample is using the other part of the library, which I did not include here. But still, let's quickly just walk through the sample. Okay, so it's giving us perhaps what I can do is copy that portion from our presentation, which was part of, let me just open another version of it right here. So at the top we had this hierarchy, and so this one is trying to use this output stream. So I'll just say copy image, and open another scratch pad like that, and just paste this in. And so this time I'm just going to focus on whatever we're trying to use here. And as you can see from the sample, we're trying to use an output stream. So this time we're trying to show how you can use other parts of this library, and this time, right, we're using this output stream. Okay, so what else do? we also construct files and new output stream, okay, new output stream which generates the output stream, but we use buffered output stream. Okay, so we look at this and you can see that we're using the buffered output stream in this sample, right, which itself derives from the filter output stream. Okay, buffered output stream. And then we also construct buffered writer. Okay, so this time the buffered writer is located all the way down here. So this sample is also using the buffered writer right here, right? So it's amazing that you know, you can come up with combinations of these objects that can be used together, and so that's why we have those samples to discuss, right? Okay. So we construct this buffered writer and we take this output stream writer, which takes the output, which is this output stream object. So output stream writer, just to make sure that this output stream writer is, where was it? Let me scroll up a little bit. Output stream writer right here, right? So we use this object right here when we're constructing this final version. So far we've used 4 of them in this hierarchy of objects, right? And we were able to construct our writer, which is the one that we use to write the information into the file. Okay, and the way we do this is that this time what we do is we collect obviously the ID number as an integer, okay, then we collect the name of an employee, of course, as the name, which is the string, and we also collect the pay rate, which is a double, right? So it's a double defined right here. So this is a double precision floating point number. And then what we do is that we construct the string object that constructed from an ID, the delimiter, the name, the delimiter, and another pay rate. Then of course the delimiter that we use is simply a comma, right? So it was just being defined as a string, and it's a comma. And then we say writer write, and we say take the string from us, starting from the beginning of the string, write the entire length of it. So this is just an example of how you can use other parts of the library to write a character stream. Okay. And the writer has another method, which is new line, and this way you're inserting a universal, you know, new line character into it. So let's see if our slides actually elaborate on this specific example. Sequential output of ASCII files. So this the buffered input stream object implements input stream of bytes. Oh, this is let me see. No, I'm sorry. This is the counterpart of what we just did. This is actually the reader part of it. I apologize. This is the reader part. Perhaps I can save this segment.